Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about Lego question number 376, Wiggle subsequence. So a wiggle sequence is a sequence where the difference between successive numbers strictly alternate between positive and negative. The first difference may be either positive or negative. A sequence with one element or a sequence with two non-equal elements are trivially wiggle sequence. For example, see here 174927 is a valid wiggle sequence because this 1 and 7 difference is 6, right? 7 minus 1 is 6 and 4 minus 7 is minus 3 and 9 minus 4 is equal to 5, 2 minus 9 is equal to minus 7 and 5 minus 2 is equal to 3. So see here, one is positive, another one is negative, one is positive, another one is negative, one is positive, like that. Here starting may be a negative or maybe a positive. That's not the case. But when it is started, after that, everything should be in an alternate format. Okay. Now, in contrast, see here 14725 and 17455 are not wiggle sequence because see here 1 and 7 is increasing. Again 1 and 4 is increasing. Again 4 and 7 is also increasing, so it is not a wiggle sequence. Okay, similarly here 5 and 5 means it is not increasing, not decreasing, it is same means it is not a valid wiggle sequence. So a subsequence is obtained by deleting some elements from the original sequence, leaving the remaining elements in their original order, so it is called a subsequence. Now combine these both things. Now you want to tell them what is the longest wiggle subsequence of the nums. Okay, so they didn't told you to return the subsequence, instead they only asked for what? Length of the longest wiggle subsequence of a nums. Okay, fine. For example, we already saw about this. So here what is the sequence length? 1 2 3 4 5 6. Okay, similarly here the valid wiggle sequence is 1 17 10 13 10 16 8. So there are total of 7 values. So 7 is the sequence length. Okay, fine. So let me demonstrate with this example how we are going to build the logic. So the first easy method we can do is just take all the possible subsequence and check whether it is a wiggle sequence or not. That's it. Okay, so generate all subsequence. Okay, and what is the second step? Check whether it is a wiggle sequence or not. If it is a wiggle sequence, then just count it and take the maximum among all the sequence or all the subsequence we have found for this wiggle subsequence. Okay, so these are the three steps for the brute force approach, but unfortunately the time complexity will be almost 2 power n and space complexity will be almost O of n. Okay, so I am not get into this brute force approach. Instead we can go with some other approaches because we can solve this using a greedy approach. Okay, so we don't want to go with this backtracking and recursion approach. If you want, you may try this approach also because it requires the recursion knowledge. If you have the recursion and backtracking knowledge, and if you already solved some problems in terms of recursion and backtracking, just try to solve this using the recursion and backtracking approach. Okay, by what I mean here. Fine. So by using this we can solve this problem, or else we can take another approach called greedy approach. So let us take the greedy approach. Let me take the same example now. So see here, for this example I like to put a graph for this so that you can understand this clearly. So initially 1 and 1 and 1, so it will be like this. Now initially 7, so 7 means it will be graph will be strikes to up. Now again 4 means it will be down. Again it is 9 means graph will be up. Okay, now again 10, so here 9. Okay, now again 10 means again it will be going to the top. Okay, now again 2 means it will be going to the down, something like here. The graph is not perfect, but still I want to draw this. Okay, 2 Now again it is 1, so it comes down and it will be 1. Again it is 5, so go up, it is 5. Now if I ask you what are all the Wiggle subsequence we have, let me finish this. What are all the Wiggle subsequence I have? You will be telling like, hey, take this one, okay, and go to the top, or take this one, so it will be not confusing you. Take this one and go to the top to 7, and again come back to 4. Again go to the top either to 9 or to the 10, so that you will be reaching the maximum height, and come down again. Take this 2 or take this one, anyone. Okay, so I'll be preferring this one. Again go to the top. So basically a Wiggle sequence is like this. Can you understand this? Low, high, low, high, low, high. That's the reason why when we are computing the difference between those two alternatives or the neighbors, it will be like positive, negative, like that. For example, see here this line will be like 6. Okay, again here it will be 4 minus 7, which is equal to 3. Again here 10 minus 4, which is equal to 6. Again here 1 minus 10, which is equal to minus 9. Again here 5 minus 1, which is equal to 4. It is alternative in nature, right? You can also use this graph to get into the logic, or you can just directly get this to get into the logic. Now I hope you understand this graph clearly, right? Now we are going to implement this graph. Okay, like it is not like implementing the graph, but we are going to implement the logic by using this graph. How we are going to implement the logic? Okay, the first step what I am going to do is, see here there are starting with some numbers that are equal. So here I have a difficulty to find whether the starting difference is positive or negative. Can you understand this? See here it is 6, but not in all cases it will be 6. Some graph will be like this also. At this point here it will be negative. Here the difference is positive. For example, if here it is 7 and here it is 1, then 1 minus 7, which is equal to 6, minus 6. So it will be starting from minus 6. Okay, to avoid these kind of cases, we want to find what is the first difference, whether it is a positive or negative with these two values, right? So there you will be having some edge cases like this example, like this. I don't know why it is not working. Okay, like this examples. Okay, so here listen this carefully. Here, what is the difference between these two elements? 0. Again, what is the difference between these two elements? It is also 0. So I prefer, first you will be starting from here, right? I prefer you to go to a particular index where its previous index is not equal to that particular index. Can you understand this? Whose previous index is not equal to its that current index. For example, if I am starting from this 1, okay, now this I will be starting from the first index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I will be starting from the first index and I will be checking whether the first index and the 0th index are same. Yes. Go to the second index. Whether second index and its previous index are same. Yes. Go to the third index. Now whether the third index and the second index are same. No. At this particular point, I can tell you that it will be giving me either an increasing curve or a decreasing curve. Can you understand the edge case we have found out? This is the edge case, and this is the mistake I done at my first try. Okay, that's the reason why I telling you this mistake, so that you will not do this same mistake and you can able to understand what is the logic behind this also. Okay, now here comes the 7. Okay, now 7 minus 1, which is equal to 6. 6 is positive, right? Positive. So to denote this, I will be taking a flag variable and making this as 1. 1 means positive, minus 1 is negative. Okay, and my result will be equal to 1. Okay. Now whether my 7 is greater than its previous value. Now previous will be equal to 1. Okay, initially come up with me. Now 7 is greater than my previous. Yes, and also flag is also representing what? 1, which means it is correct. It is valid subsequence. It is valid wiggle subsequence. So now I'll be making my flag to -1 and making my previous value as 7, as 7 is included in part of my subsequence, and make my result as 2 because now my subsequence has 1 comma 7 as my result. As in the question itself, they don't want us to return the subsequence, rather they want us to return what is the length of the subsequence. That's the reason why I'm taking this result, okay, and counting each and every element that are valid. Now go to the next index 4. Okay, 4. Whether 4 is greater than this 7? No. 4 is lesser than this 7. 4 is lesser than this 7, and also the flag variable is denoting what? Negative. Whether 4 minus 7 is negative? Yes, that's the reason why I am checking whether 4 is less than 7, which means I will be surely getting a negative curve, which means a down curve. Now hope you understand how I transformed the graph into a logic. Yes, down curve. So now I can tell you that it is a valid subsequence. So increase my result to 3 and make my previous as 4 because 4 is taken. 4 is taken as my part of my subsequence. Okay, and make flag back to 1 because after this we want a increasing curve. Now go to 4. Oh, sorry, 9. Now 9 is greater than 4, which means it is an increasing curve. Okay. Wait here. Now I will be making my result as 4 and making my previous value as 9, and flag variable will be -1. Can you understand this? Yes. Okay. Now 10. Okay, whether 10 is greater than 9? Yes, it is greater than 9, but flag variable is negative, which means 10 minus 9 will be giving me a increasing curve, but this -1 represent we need a decreasing curve. So I cannot take this 10 as my answer, so I don't do anything, just skip and go to the next value. So it is 2. So at this particular point, what should I do? I will be going and checking whether 2 is less than 9. Yes, it is less than 9. So, and we want what? We want a decreasing curve. So 2 will be making my decreasing curve. So I'll be taking this into my consideration. So it will be 5 and make this 9 as 2 because now we have taken the 2 as my answer. So what is the last value in my subsequence? It will be 2. Okay, and make the flag variable as 1 because we need a increasing curve next time. Can I understand this? Now again it is 1. So now it is 2. 2 is greater than 1. Okay, greater than 1, which means we take this 1 and we can go with the decreasing curve, but this 1 represent what? We need a increasing curve. Okay, so we cannot take this 1. So go to the next thing. So 5. Okay, whether 2 is less than 5? Yes, which means by using this 5 I can make a increasing curve. And this 1 represent we need a increasing curve also. Yes, so I'll be making this as 6 and make the previous as 5 and make this as -1, which means in next time I want a decreasing curve, but unfortunately we have finished this array. So what is my result? It will be 6. So what is my sequence value? Sequence value is not necessary, but still what is my sequence value I have got? It is 1, 7, 4, 9, 2, 5. So this is the sequence which I just computed here, but we only need the length of this sequence. That's the reason why I didn't took this sequence, rather I have taken this result variable. Now tell me what is the time complexity? It will be O of n because I am just computed this in a single go. And what is space complexity? It will be O of 1. So this is the time and space complexity analysis. Now let us see the code so that it will be more clear. So see here, I have written a Java code. If you want C++ or Python code, just go and search in my description. So see here, if I am just assigning the length of the nums in the n, and if I am checking whether n is equal to 0, then I will be returning 0. Okay, then result is equal to 1. I am initializing result is equal to 1. If n is equal to 1, which means I will be returning what? The result value, as they have already given here itself. See here where they have given the condition, right? I don't know where in question they have given the condition. Here, a sequence with one element with one element is a trivial wiggle sequence, which means it is also a valid wiggle sequence. That's the reason why I'm returning. If there is a length is 1, then I'll be returning 1 like that. Okay. Now previous is equal to nums of 0. Okay. Now the current index is 1 and I am doing step-by-step operation until what? Until index is less than n and nums of index is equal to previous value. Can you understand this? I told you, right? When the current element is equal to the previous element, I want to go to the next element, so that I will be getting two different elements at the start. Then only I can decide whether it is an increasing curve or whether it is a decreasing curve. For that reason only I have put this loop. Okay. Now if the index is equal to n, then I will be returning the result. How it is possible? See here, if the entire array is of ones, okay, 5 ones. Okay. Now in this while loop itself, I will be reaching the end index, which means index which is equal to the total number of length 5. Okay. In that case, I can tell you that the only wiggle subsequence I can take is a set a subsequence that contain 1. Can you understand this? So that's the reason why I'll be returning 1 when I encounter this condition. Okay. Now difference. So this difference is the flag variable that holds whether in future we want an increasing curve or a decreasing curve. Okay. So see here I'm checking nums of index is greater than previous. Then what is this? It will be 1, else it will be -1. Can you understand this? If the current element is greater than the previous element, it will be causing what? It will be causing a increasing curve. That's the reason why I initialize as 1. If it is not so, then it will be like a decreasing curve. Hope you understand this. Now come here. I'll be traversing from index up to n. Okay, and I'm checking a condition. If nums of I is greater than previous and difference is equal to 1, which means if the current element is greater than the previous element and also we need increasing curve, then what I will be doing? I will be increasing my result and making my curve that flag variable as -1, which means now in future we want decreasing curve after this. Okay. Else if what I'm doing, I'm checking whether the current element is less than the previous element. If it is so, and also my flag variable is needing a decreasing curve, then what I'm going to do, I'll be making my flag variable to 1, which means in future we need again a increasing curve and also result will be +1. Okay. And regardless of these two conditions, I'll be doing what? I'll be updating my current element as a previous element for the next iteration. Okay. At last I'll be returning the result. Hope you understand this entire code. Let me submit this. Yes, it is submitted successfully. To know about these kinds of algorithms, just go and search in my YouTube channel. And if you really like this video and subscribe to my channel. And if you have any doubts regarding this video, you can comment it out in the comment section. Thank you.